right, so the definition of parameter, that is P, and it is the true proportion in the population. Of the population. Okay. Your point estimate is the sample statistic. Okay, and the way you find this is you find P hat by taking the number of however many you're finding, right, out of your total number of sample. So for instance, when we were talking about those football players, it's how many actually recorded loss of consciousness out of the total number of football players who actually completed the survey. A standardized test statistic is the statistic minus the parameter divided by the standard deviation. So z-score for a proportion, you already know this formula. This is kind of a throwback. So p hat minus p divided by the standard deviation, which is going to be that square root of p times 1 minus p divided by n. And this one specifically, you're going to use p and not p hat when you talk about z-score. The p-value is the probability that you get a test statistic as extreme as it is if the null is true. So the probability that you get a test statistic as extreme as if the null was true. Your alpha level is the little fish looking thing. So that's if the p-value is less than alpha, then you reject the null. And normally your alpha is probably something around 0.01 or 0.05. Sometimes it can be 0.1. Okay? For evidence, that's proof of a hypothesis measured by p-value. And statistically significant is the likelihood that a relationship is due to something other than chance. So if p-value is less than alpha, then statistically significant. All right, so the question that we're going to actually investigate is, according to Google, the proportion of ads in a magazine like Vogue is 45%. Does that proportion apply to a randomly selected magazine such as Southern Living? 72 out of 161 pages had ads. Use a significance test to determine if there's a significant difference between the percent of ads in Vogue and Southern Living. Okay? So the first thing that we want to do is find our parameter. Okay, so our P is the true proportion of ads, which is 0.45, and that place I got 0.45 is from that 45%. So state your estimate or statistic. So p hat is going to be 72 divided by 161, which is going to give you 0.447. Okay, so our step 2 is going to be to state the hypothesis. Okay, so I know we struggled with the null hypothesis versus the alternate. Okay, so flipping over to the next page, it says that usually the null hypothesis is the statement of no effect or no difference. So it's symbolically written as H naught or HO. And so P equals 0.45. So you're going to assume what they told you basically up here at the top. Okay. The second hypothesis that we will formally state is called the alternative hypothesis. So that's the claim about the population that we're trying to find evidence for. Okay, so there are 3 different choices for the alternate hypothesis, but we're basically going to say for this one that it is not equal to 0.45. Okay, so down here at the bottom, it's going to be 0.45. We're going to do this one as our alternate hypothesis. Okay. So either Southern Living does have 0.45 or they don't, right? All right, so coming down here, it says, what are the hypotheses for this test? So the null hypothesis is that P equals 0.45. The alternative is that P does not equal 0.45, right? Now, we need to check all assumptions. Okay, so we need to check all assumptions. So the first one is we do a simple random sample to reduce bias. Okay, so it said that magazines are randomly selected. And you can actually go back to the original problem and see that it says random sample, right? Normality is going to be that n times p hat. And we're trying to check and see if it's bigger than 10. So our sample was 161 times 0.45, and we're seeing if that's greater than or equal to 10, which it is. And then we also want to check the other way around. So n times 1 minus p hat, is that bigger than or equal to 10? So 161 times 0.55, and that's bigger than or equal to 10. So those are both good. And so then we want to actually calculate the z-score, called the test statistic. Okay, so we're going to take what we got, right, which was our p-value, which back up p-hat value, which is 0.447, minus what our p-value is, which is 0.45, and then we're going to divide by our standard deviation. So we're going to find that by taking the square root 0.45 times 0.55, dividing it by 161. So I know that was a lot of information. You're going to get negative 0.0765. Okay. Now with this test, this is what we call a two-tailed test. And the reason why it's called two-tailed is because we said that our p-value is at 0.45, but we wanted an alternative hypothesis, which is everything else that is not 0.45. Okay, so let me make this clear. This is our null, and the black stuff is what we're trying to find. Okay, so it's two-tailed since HA does not equal 0.45. Okay. Now remember, when we actually pulled our sample, we got 0.447, right? Which is right. Okay. So on the next one, it says the p-value is the probability that you get a value as extreme as your test statistic if null is true. Use table A to calculate the p-value or normal CDF, lower bound, upper bound, mean, standard deviation. If you use the two-sided alternative hypothesis, you have to double the table probability because you did not know if the sample mean was greater than or less than the population mean. Okay, so this is something really important. When you're running that two-sided alternative hypothesis, so when it could potentially be on both sides, you're going to multiply it by 2. Okay, so you're going to do 2 times the normal CDF. Okay, and the way you get that is you hit in your calculator, second var, scroll down to normal CDF. And so our lower bounds could be, could put negative infinity, but we could also put 0 because it could have no adds, right? And then you've got 0.447. Yeah, go ahead. Okay, so if you go into that, your lower bound is going to be like negative infinity. Okay, because we want to get as far to the left as possible, which is going to be like -1 e to the 99. That's about as close as you're possibly going to get. Okay, and then you're going to have 0.45, which is your mean. And then your standard deviation is going to be that square root of 0.45 times 0.55 divided by 161. You could also use your z-score, and you could do the normal CDF and put the z-score in instead, and then you could just put 0 and 1 for these two things. Doesn't matter, you'll get the same thing. Which is going to equal 0.939. Okay, so if you want to take a moment and try putting that into your calculator. Alright, so interpreting your results. Most of the time we use p-value rather than the test statistic to determine if your sample proportion is unusual. Suppose the p-value is 0.02. Then assuming that the population proportion is really 0.45, the probability that you get a sample proportion as extreme as the one that you got by chance variation is 2 out of 100 times or less. That's pretty unlikely to happen by chance. So you would believe that the true proportion is probably not p equals 0.45. Okay? So then that says to interpret your p-value. Okay? So the probability that we have a test statistic of 0.447 if p equals 0.45 is 0.939, and this is very likely. So there is insufficient evidence to reject HO. Okay? So it's really likely to have something that's going to be like 94%, right? So it's likely to happen, so you're not going to reject the null.